I think we are on the record, right? It says recording. So I'm not an expert on Zoom. Like Zoom, এই first আমার use করা লাগতেছে just because Google Meet disabled their recording feature আর কি। Hmm. Okay, so thank you everyone for waking up early. I know 9:30 classes are not fun. You have to wake up early and it's a pain, but thank you again. So let's start. Today is what, lecture 3, right? And the goal for today's lecture will be to talk about some simple stuff like real number system. Then we'll talk a little bit about polynomials. And we'll also look at some basic geometry or basic Euclidean geometry. That will be today's plan. So let me just start with real numbers. By the way, is this background bothering anybody? The page template or the paper background?
No, sir.
No, sir.
Okay, so if you have any issues, like I get the fact that some people might be, this sort of a repetitive pattern might be disturbing for somebody. So if it's disturbing for you, let me know. I'll change the page template. Okay. All right. So real numbers. Well, how do I say what is a real number? Well, how do I say this? Okay, so in mathematics, the real numbers are those numbers that is a subset of a complex number. But I haven't taught you complex number yet, so bringing in the topic of complex number doesn't make much sense. Okay, so some people are waiting in the room. Sorry, give me a second. They just left. Okay. All right, so real numbers are numbers like this. Let's say 1, 2, 1.1, -2, -2.3. Da, 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 da. All the numbers you have dealt so far in your career are just real numbers. And the set of real numbers are denoted by R. It's like a pretty bold face, big R. Okay. And what we can do, we can classify the real numbers as follows. So let's say this is the set of real numbers. You can classify them as the following. There are two main categories, and those are known as rational number and irrational number. So let me define what is a rational number and what is a irrational number. So rational numbers, the set of rational numbers is denoted with this Q. Like even I can't write it properly. It's like a bold face Q like this. Maybe they write it like this, or some people write it like this, like draw two circles and then put a Q, a tail like this. So these are numbers. Let's say I'm denoting an irrational number with X. such that X has this form P by Q, where Q is not equals to 0 and P and Q are co-prime numbers, or so to say, they cannot divide each other. So even if I don't use the word co-prime and I'm saying that P and Q are integers, such that P can't be divided by Q with a remainder of 0. This means not divisible. Okay, there are 2 more people in the waiting room. Okay, I think I accepted them. All right. So let me show you an example. Maybe this will clear things up. For example, 3 by 5 is a rational number. Then what else do we have? We can have a number like this. Let's say 5 by 2, which is just 2 point what? Is it 2.25? Yeah, this is also a rational number. Then we can have numbers like this as well, 1.6.
And I think it's 2.5.
Oh yeah, sorry. Thank you. So yeah, you are right. This is also a rational number. Then we can have decimal point numbers. Decimal means this dot. And let's say this number is 1.6, 0, 1, 0, 1, 0, 1, 0, 1, dot, 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 dot. It goes on and on and on. This is also a rational number. So why this is a rational number? Well, let me see if I can find a good example for this. Yeah, so consider an example, 10 by 3. And if you divide it, it would look something like this, right? It would go on and on and on after the decimal point. But what you can notice is that there is a repetitive pattern. And I think some people will write it like this. 0.3 bar means it goes on and on and on. Similarly, in this example, the 0, 1 repeats itself. So you can just write it like this, 1.601, then there is a bar. So this is also a rational number. And if it's a rational number, you can always express this number as a fraction like this, 10 by 3, or so to say P by Q. You can always do that. Yeah, so these are called rational numbers. So can anyone tell me if the integers, either positive or negative, are rationals? Do you think the integer numbers are rational numbers?
Yes, sir.
Why?
Because কারণ এগুলোকে p by q আকারে লেখা যায়।
Okay, so let's say I take an integer, let's say 2. How can I write it in this format? This P by Q, where P and Q are co-primes. What is P and what is Q? Well, I mean, this is what you are saying, right? This is P by Q. So can you tell me what is P and what is Q?
Sir.
Yeah,
And
2 by 1, sir.
exactly. What about the number -3? Is this a rational number?
Yes,
Yes,
sir.
sir.
Because of the same exact reason. So from these examples, what you can conclude is that the set of integers is a subset of the rational numbers. So the set of integers which is denoted by this symbol Z is a subset of the rational numbers. Okay, good. So any questions from rational numbers? Sorry about that. Yeah, any questions? If not, I'll move on. So yeah, and what are now what I can do, I can just define the set of integers. The set of integers contains numbers like this.
Sorry, is that Z the set of integers?
Z, but you know, you put a line like this one. Z is the set of integers, yeah. 1, 2, 3, da, 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 da. Goes on and on and on. So this is your set of integers. And then from the set of integers, some people define another subset that is the set of the positive integers. And some people call it whole numbers. I don't know why they call it a whole number or something. What they do for this set, which is denoted with Z plus or whole numbers, is that they just get rid of all the negative numbers. But I don't want to call them whole numbers. I would rather call them, you know, set of positive integers. So this set will contain numbers like this: 0, 1, 2, 3, and so on. And there is another subset of the integers that are called natural numbers. They're denoted with this n symbol. This n is a subset of Z, and n will contain elements 1, 2, 3. Da, 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 da. So note the fact that 0 is not a natural number. Why? Because you cannot divide by 0. It's not well defined. That's one way to look at it. So I think I covered pretty much everything inside rational numbers. I covered integers, whole numbers, and natural numbers. Yeah, so any questions so far? These are just definitions.
Sir, what's the difference between whole number and natural numbers? Is it the only zero?
Yeah, I mean, they call it whole numbers, but it's really the set of positive integers. Yeah. So you just get rid of 0, and then you define another set that is called the set of natural numbers. And I think the reasoning comes from this fact that there are like 4 basic operations, right? Not 4, actually 2. One is addition, another one is multiplication. But another subset of addition is subtraction, and a subset of multiplication is division, right? So if you keep 0 inside your set, you can do addition, multiplication, subtraction, but you cannot do the division, you know, for basic counting purposes. But if you get rid of 0 and define this set of natural numbers, then you can do all 4 of these operations without any issues, because division by 0 is not well defined. In fact, it is not defined. It's just not well defined. It's not defined at all. Nobody knows what happens when you divide by 0. So I think from there this logic came. I don't know. I don't know the historical context. So yeah, but this is my idea of looking into things. Does that answer your question? Um, if so, then should I move on? Any more questions? Can you hear me though?
Yes, sir.
Okay. So no more questions, right? From rational numbers, natural numbers, or episode of integers. Okay, so let's move on. So yeah, these are all the subcategories of rational numbers. So now let's define irrational numbers. What are irrational numbers? Anything or any number that is not rational. And an example is square root over 2. This is a irrational number. Square root over 3. This is also an irrational number. Square root over 5, and so on. Then there are natural constants like the pi. This is irrational. Then the exponent or e, this is also irrational, or the Euler constant. Sometimes it's called the Euler constant. These are all examples of irrational numbers. So what happens in reality is that you take the set of real numbers and you divide them into irrational and rational. And inside rational, there are subcategories. Those are Z plus, that means integers, whole numbers, natural numbers, and so on. So real number is, the set of real numbers is made out of irrationals and rationals, and you have more. There's a fun fact is that you have more irrational numbers than rational numbers. You can prove it if you are taking an analysis course, but we are not going to do that here. It's outside the context of the course. Okay. Yeah, that's pretty much it about real number systems. And all these numbers that we talked about, these rational or irrationals, what they do is that they make up the real number line, which is a visual aid to get a feel for what do we do when we are dealing with one-dimensional equations or inequalities and so on. So the idea of real number line is pretty simple. You draw a straight line like this. You put a 0 over here somewhere. Let's switch to another color, maybe that will be better. Then the positive numbers are denoted on the right side, and all these units are equal, and these are of 1 units. Okay, that's messy. So, yep. So if this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7. And in between 0 and 1, there are decimal point numbers. For example, 0.5 could be somewhere about here, 0.3 could be somewhere about here, and so on. And on the left side, you get -1, -2, -3, and so on. This is the real number line. Is that okay? Any questions? Okay, so if not, let's move on. Now, what I want to tell you is something about intervals. Interval means how to say this? Let's say you want to select all the numbers from 1 to 2. Let's say. How many numbers are there? Well, a lot, right? Because you can have 1, you can have 1.1, you can have 1.0000, 1, and so on. So how do I express this? It's pretty easy. We express this in terms of intervals. I want to have an interval on the real number line that will contain 1 and 2 and all the numbers in between. So this is what I want. I want to have all the numbers between 1 and 2 such that 1 and 2 is contained in that set. Let's call it a set because at the end of the day, these are indeed collection of numbers and we can obviously call it a set. So such that 1 and 2 is contained and all the numbers in between them. So the way to express that set, let's call that set X, is just put third brackets or third braces and write like this 1 and 2. So these third braces, they mean that 1 and 2, both of them are contained. If you want to construct another set, let's say X prime, or let's call it X1, that will contain 1 but not 2. So what you do is that you put a third brace on the left side of 1. You put 2, but now you put a first brace like this. So this first brace will mean that this interval does not contain 2, but it can contain all the numbers before 2. Can anyone tell me what's the number before 2 in the real number line? Let's say this is my real number line. This is 0, this is 1, this is 2. What is the number just that comes just before 2?
1 point something.
1.5.
1.9.
What about 1.999999999 and goes on?
Yeah, that also.
Yeah, so yeah, there is no exact answer for this one. I don't know. That's it. We don't know what that is. Yeah, so this is the notational thing that you need to know, that if you have a first base inside, that means you are taking 1 like this, then you are going up to 2, but you are not including 2. So you are stopping at the number that is before 2. Quantitatively, you cannot express it, but in a real number line, you can. This means leave 2 alone, but contain everything from 1 up to 2. Okay, so this white highlighted part, this will indicate this. 1, 2 interval. And now let's consider another set or another interval. In fact, this is called a half open interval. Why open? Because you're not taking 2 inside. This is a very informal definition. The formal definition would involve the idea of open sets, closed sets, and so on, epsilon neighborhood. Those are part of analysis. I'm not going to go there for this course. Okay, so let's consider another and probably the last example for intervals is an interval like this. Let's say -3 to -2. But this time I wrote it in first braces. So what does this mean? This means I'll have all the numbers between -3 and -2. But this set does not contain -3 and -2. So if I want to draw a real number line like this, let's say this is -3, this is -2, -1, 0, and I'm not drawing the right hand side. So this means an interval like this. So this set x2, it does not contain -3 and -2, but it contains everything else in between them. This blue highlighted area. Okay. So the very first example that I used, the third braces that contain 1 and 2, both these type of intervals are called closed intervals. Even though, again, there are some complications there, but again, those are part of analysis, so we're not going to go there for us. If you see third braces on both sides, that means it will contain 1 and 2, and this type of interval, you can call it a closed interval. This type of intervals over here are called half open, or you can also say half closed. And this type of intervals are called open intervals. Any more questions regarding this? And this will be helpful when you study functions, especially when you are considering domains or ranges and so on. These ideas will be in use.
Sir, can you tell the definition of interval again one more time?
Oh, this is the informal definition that we are dealing with, not the formal one, because that's a part of analysis. So interval is, you can think of it as a set, okay? It's a set, and I gave out a particular example that I'm on the first one. That is, I want to have all the numbers between 1 and 2, including 1 and 2. That means take 1 and 2 and also take all the numbers in between them and make them a set. That's interval.
Isn't that a lot of numbers, like 1.111, 1.
Yeah, but we can obviously draw it. We can express it like this one. That's it. There is a lot of numbers in between them. And just by considering an interval like this, you can show that the just between this space, this space over here, in this highlighted area, just between this space, you can consider this space and you can show that the irrational numbers contained within this highlighted area is more than the rational numbers. So if you're interested in those things, grab a book on analysis, like real analysis or something. We won't cover this in this course, but yeah, that's a lot of numbers, you were right. And fortunately we have a way to express them and, you know, work with them.
Is this mentioned in Sullivan's book?
Nope. The intervals are there, but I don't think Sullivan's book talks about whether the irrational numbers are, I mean, why the irrational numbers are, you know, large in quantity rather than the rational numbers. Sullivan's book won't cover that. It's just an algebra book, not an analysis book. So let me just put a side note like this. If you're interested in this sort of stuff, like open sets, difference between rational and irrational, grab any.
It's quite hard to read, sir.
Oh yeah, sorry. Okay, so let me just say this again. Okay, I don't know, my handwriting sucks. So if you're interested in this kind of things, like, okay, you are saying that, okay, there's a lot of number in between them, but how do you really work with them, or how does any of this makes any sense? So just grab a real analysis book. Pretty sure none of you will like it, because those are things done by mathematicians, and those things are pretty unfamiliar to you, I think, unless you have an Olympiad background, obviously. And those logical constructions stand on the ground of axiom, theorems, and lemmas. So I'm not sure whether you'll really like it, but if you really want to demystify or debunk all these stuffs that I'm saying, because in this course we cannot go into such details, and to be very honest, it's not that appropriate for for you people. So if you really want to debunk them, go and grab a real analysis book. I mean, we'll just state some facts or say, oh, this happens, but you might ask, okay, why that happened? There is obviously a proof there, but that does not mean the proof contains, easy stuffs or basic stuffs. So a lot of the time, what we have to do in this course is that we have to skip the proofs. We'll just give out some statements. We'll just give out some examples and some ways to deal with the algebras or the maths that you have to do. So all these stuffs will seem very weird unless you know the proper explanation. But unfortunately, the proper explanations are in real analysis books. That's it. Yeah. So any questions so far? Okay, if not, what did I talk about so far? I talked about real numbers, I talked about intervals, and I wanted to talk about geometry and polynomials, right? So let me talk about some basic geometry first, then we'll get into the business of polynomials. So some basic geometry. These are high school geometry stuff. And we'll start with the concept of a distance. Let's take the real number line again. Say this is 0, 1, 2, 3, -1, -2. And let's say I want to define a distance between 0.1 and 0.3, a distance d. The distance is defined as follows. Let's say you have 2 points, 0.1 and 3 in this particular example. What you do, you take the last point or the end point, then subtract the initial point and put a modulus sign around it. What is the modulus sign? Modulus sign is something like this. X, modulo x means just x, and if you have a, let's say, modulus of -x, that also means x. So what does this sign tell you? This JL sign or the modulus sign? Well, it just instructs you to get rid of the minus sign if your expression overall contains any. Okay, so in this case it doesn't, so this is just this. What about the point, let's say 2, I mean -2 and 2? What about this one? Let's call that D1. The endpoint is 2. You can also select the endpoint to be -2. It really doesn't matter since you are using a modular sign. So this is -2. Then I have to subtract the other point, 2, like this. What we get is -4, but there is a modular sign, so this is just 4. So that means there is a 4-unit distance between -2 and 2. And you can verify this if you want. This is 1 unit. This is 1 unit. This is 1 unit, and this is another unit. So 1, 2, 3, 4.
ক্লাস বুঝতেছি না খাবো না এখন খাবো না জুমে ক্লাস পরে রেকর্ডিং করা লাগবে এখানে
4
ক্লাস
units.
Your mic is on.
রাখো পরে খাইতেছি নাস্তা
Yeah, so do you get my point? Why it's called 4 units? Because 2, 1, 1, 0, 0, -1, -1, -2. Oh, by the way, অনলাইন ক্লাসের সুবিধা হচ্ছে তুমি ক্লাসের মাঝখানে খাইতে পারবা। ইটস ফাইন। আমিও ক্লাসের মাঝখানে খাই, ওকে? তোমাদের সাথে কথা বলার মাঝখানে আমিও খাই। So it's fine. Have your breakfast. Acha, so do you get the point why it's called 4 units? 4 units of distance.
Yes, sir.
Okay, good. So that is the concept of distance. So if I want to write in general, if I have 2 points such that x1 and x2 belongs to the real number line, and they can be positive, negative, anything. The distance between them let's call that D is given by x1 minus x2 or x2 minus x1, vice versa. Now I want you to show you some, I want to give you an exercise, and it's pretty simple. Again, these exercises are ungraded.
x1 এর পর কি
Sorry.
x1 এর পর
Oh, that's a
হচ্ছে x-
minus.
না না উপরে first in
Oh.
general x1
This is a comma.
এটার পর
x2
x2
belongs to R.
স্যার আই থেকে একটা উইয়ার্ড আওয়াজ আসতেছে আর কি এটা কি স্যার কার মাইক থেকে আসতেছে স্যার
I don't think it's mine, right?
I think it's Jerin's.
আচ্ছা, so Zerin, তুমি যেটা বলতেছিলে x1 and x2 belongs to R, এর real number আর কি, বা real number line এ belong করে। Is that okay?
স্যার এই কনসেপ্ট আমি বুঝি নাই
ও মানে তোমার রিয়েল নাম্বার লাইনের উপরে দুইটা পয়েন্ট আছে, একটা x1 আর একটা x2, এদের মাঝখানে যে ডিসটেন্সটা সেটা আমি ডিফাইন করতেছি এইভাবে আর কি। x1 মাইনাস x2 এই দুইটা নিবা, তারপরে হচ্ছে জাস্ট টেক देयर মডুলাস আর কি। দ্যাটস দ্য আইডিয়া অফ আ ডিসটেন্স। আচ্ছা, তুমি স্কেল দিয়ে একটা অবজেক্টের লেন্থ মাপো কিভাবে?
স্যার ইঞ্চি হিসাব করে মাপি
সো আমি ধরো একটা অবজেক্টের স্টার্টিং মানে একদম ধরো যে এটা একটা আই ডোন্ট নো একটা বক্স অর সামথিং, এন্ড দিস ইজ মাই মিটার স্কেল, রাইট? সো এখানে ধরো লেখা আছে 5, এই পয়েন্টটা আমি 5 পয়েন্ট এটার সাথে অ্যালাইন করলাম, আর এখানে তারপরে আমি এখানে পাইলাম এন্ড পয়েন্ট পাইলাম 3, তাহলে এটার লেন্থ কত?
2
এক্স্যাক্টলি, এখানে সেটাই হইতেছে। ইনফ্যাক্ট এইখানে তুমি যা করতেছো সেটা আসছে এই জায়গা ডেফিনেশন থেকে।
জি স্যার বুঝতে পারছি
Okay, so this is how we define distance, and now what I want you to do is that I want you to show that t is equals to x2 minus x1 as well using this definition. Definition and the property of modulus. It is very obvious. Modulus means check here this. So try this out. These are not graded. I will not check them, but if you want, we can talk about it. Okay. All right, cool. So I think I'm done with defining distances. So that's the very first thing you do when you do geometry. You need to have a notion of distance. And once you have a notion of distance, you can build things up like areas, volumes, and stuff like that. So now I just want to show you something. I'm not going to the proof right now because I don't think I have much time. Like I have what, like 30 minutes left, I guess, and I need to cover a lot. So I want to introduce the concept of distance in 2D geometry, because we only introduced the concept of distance for a line, right? Now I want to, extend that into a 2D geometry. So let's say this is a plane, a surface, and again, I haven't introduced anything like coordinates or coordinate systems, but we'll get to that. So that's why I'm not going to show you the proof right now, but when we do introduce coordinate systems, I'll show you the proof. Okay, so let's say I have a point like this P, and this point is labeled by two numbers. One is X, one is Y, and both X and Y will belong to real numbers. And this O represents the origin, which is labeled by 0 and 0. Okay. Now, if I draw a line like this, let's call this line OP. And I want to compute the distance between 0, or so to say the origin, to P. Or I can write as D of OP or tail of OP, really doesn't matter. And this distance is just given by this. And we will prove it once we introduce coordinate systems, functions, and all that things. So why bother introducing a distance in 2D? Because if you have a triangle like this, and I ask you what is the area of this thing, right? You need to have a notion of distance in 2 dimensions. Why is it 2 dimensions? Well, you can independently move in 2 ways, or so to say, you have 2 degrees of freedom. That's why it's called a 2-dimensional thing, so to say. So it's important to define this notion of distances. Without them, you cannot have areas, volumes, anything at all. Or if you have a square like this, you need the notion of distance to first define the arm lengths, and then you get an area like a square or something. In this case, you would get a base and a height, right? This would be your base, this would be your height, and the area would come up as 1/2 of P and H. But if you don't define a notion of distance, how would you define base and height? That's the question, because you can always drag this triangle over here like this. And if you don't have a notion of distance, you don't even know what is base or what is height, right? And without those things, you cannot define the area. So yeah, that's the notion of distance in 2D. If you don't understand it right now, let me give a minor spoiler. This is just Pythagoras' theorem. Okay, but we will prove it later. Okay, so that's sort of a basic 2D geometry that we wanted to talk about. And we don't have much time, so I'll have to move into the section polynomials. Okay, any questions so far? Okay, so if you don't understand the 2D thing right now, that's fine. we'll get back to this thing later in the course, but do you understand the notion of distance in one dimension, or so to say on the real number line? Do you understand that?
Yes,
Yes,
sir.
sir.
Okay, good.
Sir.
Bolo? Oh, okay. Okay, yes, sir, will such a fine. Okay, so yeah, polynomials. Well, what is a polynomial? Okay, there's a lot in polynomial. I don't know which one should I cover first, but let's define polynomials first. Let's say you have something like this, an algebraic quantity. Um, any quantity, like this format is a polynomial. This a1, 2, 3, dot, 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 a of m, all these things are real numbers. And these x's are variables. Also, these m's are integers. Does that make any sense? Well, if it doesn't, let me show you an example. 2x squared plus 2x plus 1. We call it a second degree polynomial. Why we call it a second degree polynomial? Well, first of all, just take a look at all the x's, all the variables, okay? And notice the highest power in this thing. In this case, we have a 2, right? So that's why we call it a degree of 2, or a polynomial with a degree of 2. So what is a polynomial in general? Well, a polynomial is something that contains more than one terms. For example, if you had a quantity like this 2x, it's called monomial. If you have 2x plus, let's say, 3x squared, I think it's called a binomial. In other words, this is indeed a polynomial, like many legs or many terms, whatever you want to call it. I think that's the translation of polynomial. Like it has many legs or many arms, something like that. In a mathematical context, it just means there is more than one terms. Then you can have another term like 2x, 3x squared, 4x cubed. This is called a trinomial because there are three terms, 2x, 3x squared, and 4x cubed. And this is also a polynomial, and so on. So in general, you can call all of these quantities that you see, you can call them as polynomials. In fact, a monomial is also a polynomial. Why it is a polynomial? Well, it's not a proper polynomial, but it's a polynomial with one term, like it has only one legs or something. So most of the time we just don't call it a polynomial, we just call it a monomial. That's it. But if you have more than one term, well, just you can just call them polynomials instead of binomial, trinomial, and so on. And whenever we are dealing with any sort of expression like this, we look for the highest power in the variable. And in this case, the highest power is what? M. So this will be a mth degree polynomial. You can have an expression like this, 20x to the power 100 plus 2x. This is in fact a 100 degree polynomial. Well, you can ask, okay, you wrote something like this. The first term should contain x to the power m. Then there should be a term of x to the power m minus 1, x to the power m minus 2, and so on. So what about those terms? Where is my x to the power 99, x to the power 98, and so on? Well, see these coefficients over there, 1, a2, a3, a1, and so on. They can be 0 as well, right? So in this case, the coefficients, okay, so these numbers are called coefficients. Okay, so if you want to know, these are called coefficient. বাংলা সহগ বলে আর কি. So in this particular example, the coefficients are 0. That means the coefficient of x to the power 99, x to the power 98, x to the power 50, blah blah blah, all this is 0 apart from 2. That one is 20 and 2, which are coefficients of x to the power 100 and x to the power 1 respectively. And sometimes a polynomial will be written like this. Let's say p of x is equals to 2x cubed plus 3x plus 1, like this. And let's say I ask you, what is the coefficient of x square? Can anyone tell me what this is? The coefficient of x square?
Sir, 0.
1.
1. Okay. So someone said 0 and someone said 1. Can you guys explain why it should be 0 or why it should be 1?
স্যার এখানে x স্কয়ারের তো কোনো সহগই নেই, এটা তো মিসিং।
Okay.
তাহলে আমি 1 কিভাবে বলবো এটা?
Okay. So what about the person who said 1?
1 doesn't need to explain, I mean that it's hidden.
But you are adding things, right?
Yeah.
If you add 1 plus x, or let's say 1 plus 2, that becomes 3, right? But if you multiply 1 times 2, that is just 2. It doesn't change thing when it comes to multiplication. 1 doesn't change things, but it does change things when you are adding stuffs, and you are just adding stuffs here. So let me break this down for you, and after this, I think you should have no problem. So let's look at this term, 2x cubed plus 3x plus 1. I can write it as 2x cubed, 0 times x squared, 3 times x, 1 times x to the power 0. Because x to the power 0 itself is 1. And there is no existence of x in this thing. In fact, what I can do, I can just write it 2. So this will be 2 times x to the power 0. So the coefficient of x cubed is 2, coefficient of x squared is 0, coefficient of x is 3, and coefficient of x to the power 0 is 2. Okay.
স্যার কোএফিসিয়েন্ট থাকাটা কি ম্যান্ডেটরি?
Obviously. Without coefficient, what are you gonna do? Like, even if you write something like this, what do you think the coefficient is? It's just 1. For example, instead of 3x, if you had x plus 1 like this, what's the coefficient of x? The way polynomials are defined like this. So once you establish something by definition, there's no way you can say, oh, whether it's mandatory or not. So yeah, it's mandatory. I mean, without coefficient, that doesn't even make any sense, right? What are you going to do with something that doesn't have any coefficients? There's no point in adding it in the first place. Okay. Any more questions? If not, so let's now talk the roots of a polynomial. I wanted to show you something else before I go into the roots of polynomials, but I don't think I have much time. So roots of polynomials. Let's say we have a m degree polynomial p of x, which is a m degree polynomial. It's not important to have its representation right now because you already know how what a polynomial looks like from this definition? What are the roots? The roots of a polynomial are quantities. Let's call them xi. I can run from 1 to m. This is a running index. And these xi's are entities such that p of xi is 0. This is the definition of a root. Let's take an example. Let's say I have a polynomial like this. And I ask you to check whether x equals to -1 is a root of this polynomial. So what do? Well, just put x equals to -1 in this expression. So this is -1 squared, 2 times -1 plus 1. 1 squared is just 1. 2 times -1, that is -2 plus 1. So this is 0, right? If that's the case, you can say x equals to -1 is a root of p of x, where p of x is given by x squared plus 2x plus 1. But the question is, how do you find these things out? Because in this case, you just have to check, right? But what if I give you an expression like this? And ask you to find the roots. How do we do that? So that's where the idea of factorization of polynomial comes in. But we'll talk about that later. I just wanted to define the roots today so that when we do some algebra, I think I need to take a class on algebra because I don't think everyone is familiar with all these concepts. And so what I will do is that I won't go further into complex numbers. Like I'll just introduce the concepts of complex numbers, but then I'll take a class on algebra, the basic algebra that everyone needs to know. So for now, just keep this definition in your mind. We will see how to work with these things when we talk about algebra. Okay. Any question regarding this root? What is a root? Root of a polynomial? No? Okay. So, okay, let's see. So we discussed about real number systems, some basic geometry, and then we talked about polynomials, right? So we now have all the, all the ingredients that we need. So I will not continue anything today because I do think I need to take a separate class on algebra. So what I'll do in the next class, I will talk briefly about complex numbers. And then I want to, how many classes do we have? Like 3 more, right? So the next class will be on complex numbers and the rest of the classes will be dedicated to algebra. Because I do think you need to have a solid algebra background to continue with this course. So what I recommend you to do is that, pick those books up like the Sullivan's one or any other algebra book you like. And if you are following Sullivan, read through the review section, especially from Algebra Essentials. I think it starts from page 17, and read all the sections. So from Sullivan, section R, that means the review section, from page 17 to 81. That means you need to just have a look. If you don't understand things, that's fine, but just have a look on these things, okay? So this will contain topics from Algebra Essentials to rational exponents. So do this after tomorrow's class, or you can start seeing these things right now after this class.
Sir, I have a question.
Hmm.
Sir, what if we follow the other one like this?
Same stuff. Both of
Same
the books, yeah. Sullivan, okay, so what I saw both of the books. So I'm not a big fan of the Sullivan's problems. Like, these problems are like pretty basic, and I think Sullivan lacks examples, like proper examples. But the good thing about Sullivan is that he writes in a coherent manner, so that's a good thing. The other book, well, the writing's not that good. Like, it contains all the essential ideas and stuff, just like Sullivan, but I just don't find his writing that coherent. But he has good problems on the book and good examples.
Sir, the other book, it's in algebra of propositions. This problem, statements, conjunction, disjunctions, negation. This
What
one,
are you talking about? No, that's a pure math book you are talking about. Propositions will only appear in a pure math book, not in a basic algebra book.
okay,
So
but
this book is called Algebra for College Students by Leal, Hornsby, and McGuinness. I think that's how it's pronounced. That yellow cover book by Addison Wesley. So yeah, no, I don't think it contains like propositions and all that stuff. I think you got a wrong book. You got the wrong book. You are carrying a pure math book with you. Okay, so let's talk about these things. But yeah, any more math questions from today's discussion?
Sir, can you again say the definition of polynomial?
So polynomials are expressions that will contain some variable, and all those variables will have some exponents. These m's that you see in the screen, these are called exponents. X to the power m, x to the power m minus 1, yada yada yada. And all the numbers, this a1, a2, a of m, they are called coefficients. That is a polynomial. So if you want me to be more formal with the definition, it's a linear combination of different degrees of x. I know the last thing I said doesn't make any sense, so that's why I didn't want to say that, because you don't know about linear combination and stuff. In fact, it's not a linear combination, it's a non-linear. These are all non-linear stuff. But yeah, I mean, just look at this expression, okay? If you see things like this, that's a polynomial. That means it has more than one terms. Terms like terms that will contain a variable, exponent, and a coefficient. Does that make any sense? Is that okay? Like, does that answer your question? Look for things like variables, the x over here, coefficients that comes in front of the variable, and exponents. This these are called exponents, like this m's choose over here. These are exponents. Okay. These x's are called variables. You know, anything that's denoted with the symbol, that means we don't know it yet. So that's why it's called a variable. And these are your these are your variables. So let me just write this thing again, I think. There will be a lot of terms like this, and ultimately it will have, let's say, x of m. So this is called a coefficient. This is called a variable, and this is called an exponent. You see an expression like this, that's a polynomial. Let's say 2x squared plus 2x plus 13. This is a polynomial. It's a
Okay.
second degree. And the way to read these things off is that
স্যার একটা স্যার একটা কোশ্চেন কোশ্চেন হচ্ছে স্যার, যেহেতু কোএফিসিয়েন্টটা থাকতেই হবে, তাহলে 2x স্কয়ার প্লাস 2x প্লাস এই যে 13 এর সাথে তো কোনো কোএফিসিয়েন্টস নাই, তো এটা কি আমি নিজে থেকে ধরে নিব
13 itself is a coefficient of x to the power 0. In
যে এটা কি
fact,
এইটার কি ধরে নিব?
m minus m. না, এটা ধরে নেওয়ার কিছুই নেই. It's there.
ওকে,
এই যে এখানে যে 1টা লিখতেছি, 1টা আসলে আসতেছে তোমার x to the power m minus m থেকে, কারণ তোমার সেকেন্ড টার্মটা আসতেছে যখন a2 লিখতেছো তখন আসতেছে x to the power m minus 1. ওকে, যখন a3 লিখতেছো তখন আসতেছে m minus 2. এরকম এটা x to the power m minus m পর্যন্ত যাবে, তারপরে it gets exhausted. So that's why আর কি. So তোমার x to the power 0 coefficient 13, coefficient of x to the power 1 or just x is 2, coefficient of x squared is 2. Okay, and the way to read these things off is the following. If you have a polynomial like this, you call it a nth degree polynomial, where m is the highest power, or so to say, the highest number in the exponent. Okay. All right, so I think I'm running out of time. I have another class. So any more questions?
স্যার উইদাউট ম্যাথ একটা আউটসাইড কোশ্চেন ছিল স্যার।
Okay, so any more math questions, anyone? If not, then I'll stop the recording and we'll talk about the outside math questions after we stop the recording. Okay, so if no more questions, then I'll just stop the recording.